data visualization is covered in chapter 3. Now, data visualization can be a standalone approach to understanding data and trying to get insights from the data and making business decisions. But here in data mining, data visualization is done to understand the data and to look for anomalies in data, errors in data, and fix those errors so that as much of the data that we have in hand as possible can be used in the analysis. So our objective here is cleaning and preparing the data for further analysis. That's what we're going to use data visualization on. And in SAS Enterprise Miner, we already used a feature called Explore, and when you click Explore, SAS Enterprise Miner allows you to construct any number of data visualizations, and we used it for determining the role and level, whether nominal or interval or ordinal, for variables in a previous lecture. So the Explore button is what is that we can use in SAS Enterprise Miner. Besides that, there are some nodes available for explicitly developing graphical visualizations, and we will examine those in the SAS videos. So right now, I just want to give a brief introduction to the kind of topics that we will cover in SAS. So through data visualization, we generate summaries of data like mean, median, mode, variance, standard deviation, and we can generate charts and tables like bar charts and scatter diagrams and so on. And we used visualization in data mining specifically to discover underlying patterns, and if there are any correlations among the data. We'll talk more about correlation in a few minutes. And we can use these visualizations to decide which variables to include in the analysis and which variables are probably not useful, so we can get rid of those variables. And oftentimes having too many variables, too many independent variables, is not a good idea, and we'll talk more about this as well. So reducing the number of variables or dimension reduction is a good idea. So data visualization can help us in determining which variables should be thrown out and which variables are useful. And we can also use it to see whether there are any gaps in the data. Suppose you have say age of a customer, and we expect to see a full nice coverage of all the different ages. But suppose if in the data and we are missing specifically like age groups, say like 40 to 60, there are very few observations. Most of the observations are younger folks or older folks. So that means there is a gap in the variable. So that means something. So why is there a gap? And is it okay? You have to discuss this with the domain area expert and see whether if we do need to get data in that gap, then we can go back and collect more data to fill in the gaps. And again, data visualization will help in identifying if there are any unexpected gaps. And we can use it to identify outliers, data points that seem extreme, either on the lower side or on the higher side. We talked about this previously as well. And if there are outliers, whether those outlying values are genuine, in which case we keep them as is. And if they are not genuine, if there is an error there, maybe there is an extra zero or something, we can correct those and include the observations. And again, like outliers, unusual values. Outliers is a kind of an unusual value. For example, if heart rate, you get 1000 for heart rate, that's a problem. It cannot be correct, so that's an unusual value. And also, if you have a column that has the same value repeated everywhere, then that column is useless. So unitary value, so we can throw it out. And visualization of data will reveal that kind of information for us. And of course, erroneous data. We've been talking about erroneous data previously as well. And what kind of errors that you have, and again, a missing value, which instead of being a blank, sometimes some people may code it as a zero. So if you have age and you have zero for age, then that's probably missing value that's being coded as zero for age. And incorrect values could be data just plain typos or decimal points being misplaced or some kind of coding error. So when you do data exploration of interval data, then you look for what kind of problems there may be. So see whether the raw data is entered properly. Are there any extreme values? So check for numeric values within a reasonable range. Okay, like for example, the heart rate. You know what the reasonable range is. If you have a very low or a very high value, then you know that there is a problem. So check for missing values in the variables and see how many missing values are there. If there are too many missing values, and maybe that variable, either we need to collect or gather, fill in the missing values, or we should throw the variable out. And check for duplicate values and eliminate them. Again, this is something that we did previously. And you can explore the data. If it's a numerical interval variable, then you can compute statistical summaries, like what is the mean, median, mode, average, standard deviation, and so on for each interval variable, and examine those and see whether they are reasonable and if there are any extreme values. Okay, that's another source through which we can look for extreme values or erroneous values.